So what you found out when you did that activity for the area of a parallelogram being base times height is that really we can use the moving and additivity principles to be able to prove then and develop that formula. And so let's just put a couple thoughts together about parallelograms. Four-sided polygon, remember that special word polygon gives you closed and straight edges, and then with two pair of opposite sides congruent and parallel. So for parallelograms, it also includes squares and rectangles. We did that in the first weeks together where we were looking at commonalities. Also, the base can really be any side. And so you can have this guy sitting on his end like this. You can have him long and elongated like this, or like the pictures we had for the previous activity. The height then, the key is once you pick the base, the height is the perpendicular height from whatever side you choose to be the base to the opposite side. So both of these examples are showing you it outside the parallelogram. The ones that you did in that activity have them inside. And so if we choose this skinny guy as the base, we extend that out with a dotted line to then do a perpendicular height. The height falls outside, but it is still the height here of that parallelogram. And then when you have an elongated one who's sitting on a skinny side, you can still call that the base. The extension comes out just farther, and you still do that perpendicular height here. So the height of this, really, you never get it right over it, right? So you come up here, you'd have to extend that base to actually get the height. The height is, if we extended both these parallel sides, how far apart would they be? And that is that height. And as you found in the activity, the area of a parallelogram is base times height.